All right, well, I think I'll get started. Welcome, everyone. Hope you had a chance to check out the always relevant XKCD. Thank you, Nathan, for reminding me that this one existed. But yeah, this was definitely me for a while when I started using Git. Memorize a bunch of arcane commands, and if it goes wrong, just delete it and start over. I like to think I've progressed at least a little bit beyond this. There's much more arcane sounding errors that I have to see before I delete and restart, but hopefully I can get you to that level or a little closer to it today. So if you don't know me, my name's Dan Laughland. I'm a developer in the Dev Center. Have been for about 3 years. And I really enjoy using Git. So this is going to be kind of more of an intermediate talk about Git. I'm not going to cover the basics of what is distributed source control and how do you clone a repo and how do you commit things. It's going to be more about the workflows after you get into that. After you've started using Git, you know how to commit files, and you start rolling with that. So let's start by talking about what is it we're actually trying to do with Git as a tool. What are the actual workflows that we're trying to support here? And then here's the simplest one. You've got a dev, you've got a QA, and maybe it's 2 devs. They're working on a single PBI. And you want to be able to test that as they work on it. Seems pretty simple, reasonable. I think we know how to do that in a lot of cases. What about when we have 2 developers working on 2 different PBIs? They want to test both of those independently and together at different times, maybe with the same QA, maybe in the same deployment environment, and we don't want them to be stepping all over each other while they're doing that. I know feature toggles is one way to do it, and the other Dan can tell you all about that. But there are some solutions in the source control flow that we can look at too. And then there's that case, we've all been there at least once, where you've got 4 different PBIs you bring into Sprint, and one of them doesn't quite make it to done. But you still want to deploy the 3 that you got done. So how do we make sure that the undone work doesn't get mixed in with the done work, even if it's out of sequence with where you started it? Or where you started testing it, I should say. And it would also be nice if we could code review these things as a block, in a single change set. So with those things in mind, how do we use Git and its distributed model or its easy branching and all the things it can do to help support those tasks that we're trying to accomplish on a day-to-day basis? For a while now, for about 5 years, the sort of canonical way you use Git was based on this article called The Successful Git Branching Model from this guy. And he put up this chart that's very nice looking on all the different branches that you'll have and the way that you'll tag things and the way that information flows. And this really helped to stabilize the way that people use Git for a long time. It was kind of the Wild West up until that point with how people were using it. So there's some good things about this and some bad things. There was an article, a couple months ago called "Git Flow Considered Harmful," which is the, clickbait title for any kind of technology that someone's trying to smash down. But there are good and bad things here. The things I like about it are the master branch equals production. That's what you send to production. And I'm actually going to amend the way that they think of this and say that the master branch is what's ready for production. It doesn't have to be what's in production, but if it's on the master branch, it should be Scrum done. It should be ready to deploy. I like that it uses branches for new features and for hot fixes. I think that's a great use of those. And I like that they tag the releases. It makes it really easy to go back if you do have to be in a hot fix situation. You can find the release very easily and branch off of that. But it is complicated and it's hard for people to learn, and it makes your commit graphs look a little weird. What I don't like about it, if you're using feature branches in the way that I'm going to describe, having a forever living develop branch is kind of redundant. It's a piece that you don't need, and you just end up doing extra merges, getting extra commits. Same thing with the release branch. If your master branch is what's ready for prod, having a separate release branch while you prepare for release is a concept that doesn't really fit into the Agile model, or at least the Scrum model. And the diagram that we were looking at earlier, it doesn't actually match how Git works. When you're looking at a commit log, it doesn't line up that nicely. And and the arrows are actually pointing the wrong direction entirely, because that's not how commits reference each other in Git. So if you use Git flow, you can be very productive and very organized, and you will have a commit log that looks a bit like this. This is, an actual team's use of Git flow for a period of time. And if you have, the skills to filter out things in Git log and know the right commands to filter this out to look at what you really want to see, it doesn't have to look that bad. But if you're just coming onto a project and this is what you're presented with, it's kind of hard to tell what's been going on in the code base. What are people doing? So I was talking about how Git flow is kind of backwards from how commits actually work in Git. So let's take a moment and bear with me here for a slight technical explanation of what is actually inside these commits when you're using Git. So you get a snapshot of all the files. It's not a diff, it's not just the changes, it's a complete snapshot of all the files in Git. Then it's got some metadata in there, the commit message, author information, date and time, what have you. And then it has the hash, which you can think of like an ID. It's like the primary key for the commit that this one is based off of, for its parent commit. And then all of that is wrapped up and hashed, and this commit gets its own ID. So always keep in mind that if any of those three things changes, if the files, the message, or the parent, which is most important, if any of those change, the ID of this commit is going to change too, and it's not the same one anymore. So when we're talking about branching in Git, there's not really a construct of a branch. There isn't a path that you draw. You're not creating a copy of things to make a branch. It happens by virtue of the fact that you have two commits that point to the same parent. That's when a branch happens, and that's why it's so fast and easy to work with branches in Git, because there's nothing it has to create, there's nothing it has to copy. It's just part of the data structure that builds the whole thing up. So we talk about branches. It's not a line on a graph somewhere. It's not a track. It's just a pointer to a particular commit, and the entire chain of events that leads up to it is considered that branch. So if you have that shift in mindset, I think a lot of things become easier in Git if you think of branches as pointers rather than tracks in the sand that you have to follow and jump across. So when you create a new commit and you're on a branch, it just moves that pointer. That's what makes that branch continue. And what happened back at that fork point? How did we create this in the first place, right? So we have the master branch, which is the default one in Git. And then we say, okay, I'm going to create a new branch. And it just makes a pointer at whatever commit you're currently on. Again, that's the speed and flexibility of it. And you commit something on my branch, it moves the pointer. And really, you're kind of on the same branch right here, right? There's only one path until the point that you go back to master and commit something different. And now you actually have forking happening. So there's a concept of remote branches in Git, which can be a little confusing for people at first. But if you think of it as just another branch, I think it's a little easier to understand. It's just a pointer to a commit that happens to reference something on a server somewhere. So when you check out a remote branch, it's just going to create a pointer. You can actually tell it check out origin / whatever branch. It's going to say, all right, you can't actually check out a remote branch, but I'm going to make a local branch for you with the same name. So you get another pointer pointing to the same place. And this leads us to the first of several confusing Git verbs, which is fetch. So there's fetch, push, and pull. Those are all very similar sounding, but they do very different things. So fetch just retrieves all the commits from a remote server and puts them on your machine. So if Origin Master has some more data that got uploaded, it's going to download those, and that's it. That's all it's going to do. At that point, you have all the information on your local repo. You can disconnect and work with your remote branches like normal. You just can't update them, obviously. But all the data has been downloaded to you. Your pointer on your local branch has not been updated yet. Git pull is that step, doing the fetch, combined with a merge at the end. It's just a combination of those two things. So first it does the fetch. It grabs the new data from the remote. And then it does a merge. Now in this case, because everything's connected, we get a special case called a fast forward merge. This means that you're guaranteed no merge conflicts. It's not going to create a new commit, and it just kind of moves that pointer forward because it doesn't have to jump over anything. That's what a fast forward is. If you can move that branch pointer without jumping any gaps, that's what a fast forward is. You can tell it, if you don't want it to do fast forwards, if you really want to know when you did that pull merge, you can give it the no-ff argument, and then your commit graph looks kind of like this, where it's going to create that merge commit and move your pointer over. That's actually a slight mistake. It doesn't move the origin pointer until you push back, but you can tell it to create that merge commit if you really want that extra spot in your graph. It's a little more clutter, though, which people tend to try to avoid. If you have made your own commits, then you will need that merge commit. It's no longer optional. You can't do the fast forward. So if you've done some stuff locally on your master branch, and then you do a pull, and it turns out that origin master has some different information. Somebody committed while you were working, which is a very common thing. So okay, now you've got a merge. So it's going to create that commit, move your pointer over, and this is where you have the potential for actual merge conflicts to happen. This is just a reality of writing source code. There's no way to avoid it. One thing that does happen here that you may or may not like is that it creates that merge commit with its own pre-filled in commit message and whatever's in there. You can pass it -- no commit if you don't want it to do that, and then you get to go back and edit, because otherwise it's just going to say merged from whatever the URL is and the branch name, which is not always helpful. If you tell it not to create the commit right away, you can go back and revise that message to something a little more descriptive for what you're merging in or why. There's an alternative. If you don't want that merge commit in there, you can use the rebase feature of Git to make your commit graph a little cleaner as you go. So you've got your changes that you've made, and you've got the changes on origin, same as before. But now instead of creating a merge commit at the end, we're going to do a rebase, which basically just replays your changes on top of the other branch. So it's going to kind of rewind that master pointer to the last common point, go forward and make your changes again on that branch. There's still the potential for merge conflicts. They tend to be less severe with a rebase, but it's going to happen here rather than at the end, which may or may not be preferable for you. Rebase is a really interesting feature, and I'll talk a little more about it later. But when you're doing it as a pull, it's usually, and with the assumption that we're talking one central server sort of workflow, this is usually a safe way to use rebase. If you're doing it on a pull on top of a remote branch, you're not going to run into the weird, like, world-ending rebase conflicts that you hear all the scary stories about. So this is just the rebase option on pull. You can also put it in your git config to always do it this way, which is how I have it set up, because I don't like all those extra merge commits just on something that you're doing every day that's not adding a whole lot. And when you're doing these pull operations, one of the common errors that people run into is the uncommitted changes or the dirty working tree or something along those lines. Basically, it means that when you're doing a pull, you've got work in progress that you haven't committed yet. That's that sort of shadowy circle that I'm talking about. If you've made changes to files but haven't actually committed them, you can't do a pull because it doesn't know what to do with those. You can think of it like another commit. It's like, well, do I branch this now? Do you want me to rebase it? So it's just going to yell at you and say, I can't right now. So it's going to do the fetch, but then the master pointer is not going to move, and it's going to give you an error and say, you need to resolve your uncommitted changes before I want to do anything. There's an easy way to fix this. Upgrade to Git 2.6. We had like a period of time, it was like a year, where the Windows version of Git didn't get any updates. And the Linux version was up to like version 2.3, version 2.4, and Windows was still back on 1.9. They finally figured out whatever was holding them up, and now the Windows version of Git is totally up to date with all the other releases. You should absolutely upgrade if you haven't for a while, because there are some really cool new features that I'm going to cover. So Git 2.6 added this thing called auto stash. It only works on rebase operations, not merge operations. If you think about it, it makes sense. But if you have uncommitted changes and you do a pull with auto stash turned on, it will automatically create a stash set. It'll take all your changes and store them to the side. It'll do the rebase that you asked it to do, and then it'll pop your changes back on. So you don't have to worry about the uncommitted changes error happening when you have that on. It's really handy. Just be aware that like that's what's happening when you do that, because you may get confused when you come back and you're like, what? Now I'm forward and things are happening. So that is pull. Are there any questions about how that operation works? Cool. Yes.
When you do a pull rebase,
Mm-hmm.
you said that there's a potential for a merge conflict.
Yes.
When that actual merge conflict happens and I'm presented with this lovely opportunity to fix the conflict, where does the changes go into play? Is it a new commit, or is it affecting the previous commits that I made, or is it something totally different?
It's sort of in between. So when you're doing a rebase with Git, it's aware that you're in the process of a rebase. And if it runs into a conflict, it's going to stop you and say, okay, you've got to fix conflicts in these files. It'll put like all the special tags in there to show like, here's the source and the destination and all that. You go into your merge tool, you can do it in a text editor if you really want to. You resolve all that and you go back and you say, okay, now git commit. Because you're kind of in between. It's trying to, okay, I don't have, it's not going to make another commit. What's happening with a rebase is, okay, like I said, the commits, they become new things when their parent changes. So in this case, we've moved, I want my mouse to show up. Yeah. We've moved the parent of this commit from here to here, right? So the parent hash changed, it's rebuilding that commit, it's writing a new one. So if there's a merge conflict that happens, it's perfectly happy to let you edit the contents of that and then continue on because it's rewriting it anyway. So yes, it's creating a new commit, but it's basing it off of the changes you had. So the opposite of pull is push. And that is basically you're asking a server to pull from you is kind of the way to think of it. So now I've got my, my merged branches. I've got my changes. I did a pull from master. It made the merge commit. Now I want to upload that merged result back to the server. That's what push is. So I put git pull ff only from the remote point of view. Ff only meaning fast forward only. Meaning if you want to push something to a remote server, it has to be able to do it as a fast forward operation. So because there's no jumps here, it's able to upload that commit, move the pointer, and go on with life. The logic makes a little more sense if you have it on the rebase model. So I tell it to push, and it's going to say, okay, it's a fast forward across those two commits. Happy days. That's all I'm going to say about push for now. So there's this concept out there of a sync. And there are some tools that have been pervading this concept of syncing in Git, most notably Visual Studio, and the GitHub for Windows does that. There's not an actual Git command called sync. That is their construction to try and make it easier to understand, but what it's actually doing is a pull and then a push. It's trying to do that transparently for you. And really honestly, if it's just a one dev, one PBI at a time model, that's not bad because you're rarely going to run into conflicts doing that. But as soon as you start to scale up or your UX guy comes in and adds some stuff and starts syncing, now you're going to get these extra merges unless your sync lets you configure whether to use rebase or merge or something. You're going to start to get a lot of clutter in your commit graph. And it's just harder to understand what's going on when that happens. So I personally do not approve of the sync model, but if you have it out there and it works for you, then just be aware that that's just doing a pull and then a push in one operation. So to kind of recap the stuff we've just gone through, if you've got one developer working on one PBI at a time, it's a simple model. I've shown you everything you need to know. You commit your stuff, you pull, use rebase and auto stash if you think you might have extra contributions here and there. Then push your changes, and then once that gets pushed, have your CI pick it up, test it, deploy it, do your thing. Happy days. Mhm. They are. You can do them globally. Let me flip over. I can show you mine. Da-da-da. So if you go to your home folder, which will probably look something like this on Windows or /home or whatever, make a .git config file. You can enter all this sort of information. This is where your name and email address, if you need to like GPG sign your commits, because you can type whatever the heck you want in these. It's not like authoritative. But if you want it to be a little more authoritative, you can put your public key out there. Editors, aliases. So here's where I say, okay, on a pull, always use the rebase. And then on a rebase, always use the auto stash. On a pull, so this one right here only activates on a pull if you're on 2.6.3, like the newest one that came out like last week, because they just kind of forgot, I guess, that sometimes happens. But that's in there. In 2.0, the major version change, they changed what this default value is when you do a push. It used to try and push all of your branches that it had matches for all at once. With the new simple model, it's just going to push the branch you're on, which is, I think, a more intuitive way of working. And if it's a branch that doesn't exist on the remote, you do have to add a flag and tell it, hey, create this remote branch, even though you don't have a match yet. If you're on Windows and you're using Git on the command line and you're tired of typing your TFS credentials every single time, WinCred is built in as of 2.4. That uses the Windows credential helper, so you don't have to have your passwords in plain text. And then you can say, for particular URLs, here's my username. And then it'll only ask you the first time for your password, and it'll save it in the Windows password store from there on out. There's a similar thing for Mac. There's an OS X keychain cred helper that you have to install. Then if you really want to get deep into like power user or Git stuff, these are aliases that you can create. So if there's like, if I type git nope, it's the same as me typing git reset hearthead, which is basically trash all of my changes and go back to the last commit. I've also got some shortcuts for like the log format that I prefer and some other stuff. So you can add those to do custom git commands if you need to go back and forth between different models and are tired of remembering arguments. All right, so let's scale this up a little bit. Let's say you've got a couple developers on the team, and they're each working on a different feature. A really easy and sort of often used way to do this is a feature branch. So when you're starting a new feature, you make a new branch, call it feature/whatever. By convention, a lot of the graphical tools will like put that in a folder if you use that / format, which is the main reason that it happens that way. Otherwise, it's just whatever you want to call it. And then you can work on that feature, commit your changes, and then when you're done, if there's nothing else that's been committed to master, that's just a fast forward merge. You don't have to worry about anything else changing, because it's just going to slide that master pointer up to the front. If you're working on a feature branch and there has been another change on master, someone else merged in their feature that they finished before you, okay, now you have to decide, am I going to rebase or am I going to merge to get my feature onto the master branch? This is where you have to reach sort of a decision point on your project. Are we going to use the rebase model or are we going to use the merge model? And it might be different from time to time, but here's the main differences between the two. Some of them are philosophical, some of them are technical. If you believe that your source code repository is supposed to be the historical record of what actually happened, you should probably use the merge model, because it's not going to rewrite anything you've already done. If you'd rather have your source control be the story of how your project was built and what happened at various times, then rebase might be the way to go, because you would never publish the first draft of a story, and this lets you kind of go back and rewrite some of the work you've done in between to clean it up and make it easier to read. Here's the big technical reason. This is where all the horror stories come from. If the code in the branch that you want to rebase has been pushed somewhere, don't rebase it, merge it instead. The reason being, once you do that rebase, remember it recreates all those commits. They have different IDs now. The remote server kind of loses the ability to keep track of what belongs to what. So if that's already been pushed and suddenly you're rewriting the history of that commit, it's going to cause some confusion. It's not going to like shut anything down. You'll still be able to work, but you're going to get sort of a snarl in your commit logs and some duplicate data, and you won't really be entirely sure what's going on. So that's why they say don't rebase anything that's been pushed to someone else. On the rebase side, if you do have the ability to do that, the interactive mode is really cool. I'm not going to demo it today because it's kind of complicated, but you can take a stack of commits and say, okay, take that one as it is. I want to edit the commit message on this one, but leave the data as is. I want you to take these next three, squash them together as just one commit, and then leave the last one as it is too. It pops up a little text editor window, and it has the list of all the commits, and you type a little command before each one for what you want to do, and it goes through and lets you do it. And then you say rebase continue, and it goes on. If you do want to do that kind of first draft revision of your source code, that's a really cool way to manipulate commits in a way that you wouldn't normally look to do. So back to our feature branch situation. In this case, we'll say the feature branch has not been pushed to a remote server. It was just one developer working on it. They had it on their local machine the whole time. It's totally safe to rebase that onto master if you want to keep the straight line graph. On the other hand, if at one point you wanted a second developer to work on this same feature, and so you pushed it to your central server to get that checkpoint, or for other reasons, now that code has been pushed. You don't want to rebase this branch anymore because it's going to move that whole orange chain down, and it's going to rewrite the history of where it turned from white to orange, and then your colleagues are going to lose track of where that branch started because now it's part of green and what happened there. So this is where you do need to use a merge commit. Now we talked about how master is supposed to be the production branch. Like this is where things go to prod, is off of master. So think about what's happening at the point that you're making this merge commit. You're done with the PBI. There's another one that you now are integrating with. This is your integration testing phase of the PBI. So it's not done yet. So you're not actually going to merge to master. You're going to merge from master onto your branch. You're going to pull those changes up to your branch because if you do need to make a bug fix or some kind of integration bug, you want that to still be on your feature branch because it's not ready for prod until you've tested that. Once it's met your definition of done, it's a fast forward for master to go over there. There's no additional code changes. There's nothing else that's going to come into it. No risk of introducing new bugs. Once that feature branch is called done, it's fast forward to get master on there, as long as no one else has pushed to master while you were fixing it, in which case you just do the same thing again. So if that's one feature branch, what if I need to switch back and forth? What if I'm working on one and my colleague needs help on another one? Well, you can stash what you're working on. You can check out the other branch. You can do your work on the other branch. You can check out the one you were on before, and then you can reapply your work in progress. That is a way to do it. You can also make a second copy of that Git repo in a separate folder on a different branch and just jump over there. Starting in Git 2.5, there's a cool feature called work trees where you don't have to do that anymore. You can just say, Git, make me a work tree of this branch in this folder. And it'll take the repository you already have downloaded. You don't have to clone another copy. And it'll make a whole independent work tree on that repository somewhere. And you don't have to worry about synchronizing changes between them anymore because it's all coming from the same place. So if you find yourself in the position of having to switch branches a lot, Worktree is kind of a cool way to make that easier and not have to worry about synchronizing repos or stashing and jumping all over the place. So I talked about testing while you're on a feature branch. Mike has done some PowerShell foo and some extra configuration for us to make it so TeamCity can now pick up and build any branch that you want it to on Git. So now, if you want to test that feature branch before you merge it into master, this is pretty much why we had a develop branch before, right? Because we needed somewhere that TeamCity would pick up to do testing on work in progress. Well, now you can just leave it on that feature branch. It kind of removes the need for that develop branch. It becomes redundant because the feature branch is your testing branch. And now if you have two things in progress at once, you're not worrying about crossing the streams, as it were, on the develop branch. You can stay independent, test those independently, and then safely merge them to master because it's all that fast forward stuff. So to recap, when starting a new PBI, make your new branch, which is actually the checkout command if you're doing it on command line. Commit your stuff, pull, push, test, just like before. When you're done with that PBI, now you merge from master back up to your feature branch. Do any integration changes you have to do, any additional bug fixes until you've met your definition of done. Then when you merge to master, it's just a fast forward, so there's no additional code. And then you can delete your feature branch because you're done with that PBI. So you don't have an endlessly growing list of them. I also recommend when you're done with a sprint or when you're doing a release, tag that specifically. The way the TeamCity is set up right now, it'll write the version number that it generates onto that tag. But if you want it to be like release 1 sprint 16 or something, it's helpful to have those too so you can keep track of which ones you actually deployed or how far you got in each sprint. Then if you find yourself in a hotfix situation, you kind of know where to start from. So circling back to what are we trying to do here? We've got a dev and QA that want to do continuous testing on a single PBI. If they're on their feature branch and that feature branch gets picked up and built and deployed, then they're in good shape. That's easy to do. If we've got two developers working on two PBIs and they want to do continuous testing, you might have to do some database foo. The database is always the point where this is going to be terrible because that's their place in the world. But if you can keep those deployments straight and roll back and roll forward of migrations or whatever, then you can keep those feature branches separate or just have two environments if you want, and test that way. And now you don't have to merge into master until it's actually done. You're not merging to an intermediate branch beforehand. You're not blending two things together. You're actually keeping that stuff separate until you know it's done. And that also enables this workflow where you've got the one out of sequence undone PBI. If that feature branch never got merged into master, you don't have to worry about it because those other three are in master and you can deploy those safely. And the other one, keep working on it, get it next time. Code reviews are simplified in this model because when you get to that point where you're merging into master, that one commit is going to contain all the changes before it until you get to the integration point. So you can just look at that one commit. You don't have to do like the git diff foo to try and grab the chain and have it compute the total sum of all the differences. It's just the one merge commit at the end is where you can do the review at the end, or you can just keep reviewing as you go, which I think a lot of people do too. But by keeping those lines straighter and cleaner, you have less noise coming in from extra merge commits and things. So when you're doing a code review, even as you go, you've got less merge noise, and you can get a clearer picture of what's actually changing for this feature versus what's changing because things are happening. So I didn't have a lot of demos in here. It's mostly conceptual. Were there any questions that people had? I know you all use different tools, so I didn't want to dig too much into the syntax of it. Are there any questions people have? Yeah.
So if the person who's QAing is checking out, like wanting to test a feature branch,
Mm-hmm.
and they have TeamCity build that one onto the QA server, they can only test that feature branch. If they want to test a different feature branch, they'd have to have it rebuild and they'd have to switch to the other feature branch and build and deploy to test that second feature, correct?
Yes, so the question was if you have a QA who's working on one feature branch and they deploy that to your QA environment and they now want to test a different feature branch, so they have to rebuild and redeploy and all that. As you're checking in these feature branches, as you push them up to the server, they're getting built at that time. You don't have to say at the time I want to test, I need to build this. You just have to deploy it at that time, which is a shorter process. the one wrinkle in there, like I said, is if you have database migrations that are incompatible somehow, then you'll have to probably do that somewhat manually. But hopefully we'll have a better system for that someday. Yes.
I was actually thinking here, the newfound capabilities we have in being able to build feature branches in Team City and deploy those kinds of things out highlights a changing need of how we treat deploying servers. One,
Mhm.
can you recreate the whole server, from scratch as one option, or two, are database changes part of the code, right? So that you're
Right.
things like that, you're dealing with how a database can evolve such that you're deploying everything that feature branch needs to be successful on the database as part of that code base.
Exactly. Yeah. To kind of restate for the recording, when Team City can build feature branches, or any CI environment builds feature branches, that gives us a lot of new capabilities in terms of including things like database changes as part of your code, and including that along both forward and backward migrations, I would guess. So.
So that is something we talked about too when we were kind of trying this out, and although we could potentially solve the problem for like internal databases, a lot of different projects have different things that they're trying to do. So just make sure like on each individual projects you're being aware of what those weird environment things are, so that you can address them. And
Mhm.
maybe if we get to a point where 80% of the projects are seeing the same problem, we'll kind of try to address it globally. But just kind of get probably smarter to just do those one-offs.
Yeah.
Something that we're addressing manually.
And as well, if you're having problems with one of those one-offs, I've done things like that before, and I'd be happy to talk through with you on like the common databases that you need to figure out how to capture and redeploy and that kind of stuff. So that's an interesting problem.
Yeah, one of the things we're taking a look at is can we just break a feature branch, just spin up a new environment for that branch, have some common database that it starts with, and then once that branch goes away, the new branch goes. Some of the new stuff in Azure that we can access makes a lot of that a lot easier. So we're not there yet, but that is kind of on the radar of stuff to look at.
Yeah. We're talking about building environments as part of the deploy. I know the newest versions of Octopus have that channels feature, which is kind of another way to segment things. You've got your QA, your UAT, your prod environment, but you can have different channels within that, which would more or less align to feature branches. I think that gives you more filtering if you wanted to like straight up duplicate the database for each feature branch and recreate it. Maybe you have more ability to filter the variables and things based on that. But that seems to be what they're aiming for with the channel feature.
Another testing box is not really a question, but like,
Mhm.
so if, again, with the feature branches, if you are a few commits into your feature branch, developer 2 has merged their feature branch onto master.
Mhm.
So at some point you're going to have to merge master back to your branch before you merge back to master.
Right.
And you get all your integration snafus worked out. When a QA is testing, let's say that you have 3 commits on your feature branch, they are looking at your feature branch, they are testing something, they're testing your feature branch without those changes from the other feature branch at
Mhm.
that point in time. So then I think that it's good to be aware that there also has to be good communication between the developer and the QA, because they will have to know that they would need to make sure to test again after you integrate those changes into your
Yes.
feature branch.
Yeah.
That they might say, oh yeah, everything looks good, and then you are moving along, and then you need to integrate those changes we're on master back into your feature branch, and you think, okay, well, we're all good, but there might have introduced new bugs that maybe you didn't see, and that you
Mhm.
need to know that needs to be tested again.
Right. So yeah, as you're merging into master, you have to be aware that there's before and after testing that has to happen here, right? Like you test it to the point where your feature branch is done, and then you integrate, and now you have to make sure that it integrates correctly, which is a bit of a shift in process from where you might be doing that sort of as you go if you're blending 2 things together. The advantage of keeping it separate till the end is knowing where that came from for sure. The downside is now you have an integration step at the end of your PBI. You can decide amongst yourselves which one you prefer. So.
I suppose it also just, if you're working on rather disparate areas, it's probably not as big of an issue.
Mm-hmm.
But if you're working on more integrated issues, sometimes I feel like it can, the problems that I've had with feature branches in the past is just isolation issues where you're
Sure.
developing and they're developing and you're not merging until your feature branch is done and you don't realize that something they did is screwing you up and it would have been nicer to know about that earlier
Yeah.
than at the end in the integration.
To know when this is coming in.
Right.
Yeah.
And maybe that's just a communication thing again. But
Yeah.
from what I've worked with
You would hope that if you know two features are going to collide like that, if you're going to have conflicts or potential, you would be able to anticipate that ahead of time and say like, okay, we're going to work on integration today, or maybe you shouldn't be working on those two items in parallel. You should team up on one and then switch to the other, or something like that. So that's, yeah, it all comes down to communicating within your team on when things are moving where.
Nick, at the same time, it's kind of nice to know that it is an integration problem as opposed to just why is this working.
Right.
Mm-hmm. Cool. Yes.
When you were talking about feature branch, bringing the feature branch back into master,
Mm-hmm.
you said that you should merge into a feature branch
Mm-hmm.
versus merging into master. What's the difference between merging one way or the other?
It's purely a semantic difference because remember, these are just pointers. So when you say merge into my feature branch, it's creating the exact same commit. Actually, that'd be at this step. It's creating the exact same commit either way. Whichever way you merge, it's going to create the exact same change set. But now it's just a difference of saying I want to move my feature branch pointer rather than the master pointer. Because when you push that back, now you've got that semantic difference of, okay, I'm still out of feature branch. It's not in the master. It's not ready for prod.
If you're taking the changes from master and putting them on the feature
And then dealing with any potential conflicts
yeah,
on
on the feature branch instead of on master
Mm-hmm.
makes this transition faster.
Yeah, it does. And in fact, a lot of open source projects, when they do pull requests, they require that you operate this way, that you can't merge onto their master branch unless it's a fast forward, unless you've already done the integration, because that's not their job.
Talk a little bit about the code review that both GitLab and TFS have the merge request, basically code review option in those tools now.
Mm-hmm.
So if you do follow this, you can create a code review request in either of those tools and have other people take a look at it and be able to see the change set in a browser.
Yeah.
It'll just show the version that.
Yeah, if you want to do a remote code review, yeah, GitLab, TFS, GitHub, they all work on that pull request model where you can have all your changes as one set and view them that way. Great. Well, thank you all. If there are no other questions, I'll let you have 10 minutes back. And yeah, let me know any feedback that you might have. I'd like to improve this talk, see where I could expand, change things up, see what else you want to know. So thank you.